students. Last class we discussed some of the problems on the inverse of a matrix, and also we did about the elementary transformations and invertible matrices and some more theorems. So today we can discuss some more problems on the inverse of a matrix. The last class we understood about how to find the inverse of a matrix item. So now we can do the one more problem on the inverse of a matrix. In that, the next question is, by using elementary transformations, find the inverse of the matrix. The matrix is 1, 3, 2, 7. So for this matrix, we can find the inverse. Okay. So we have the three elementary operations: 3 due to row and 3 due to column. So what are the three elementary operations? In that first one, interchange of any two rows or columns, and the second one, multiplying by a non-zero number to a row or a column. The third one, the addition of elements of any row or column with the corresponding elements of any other row or column multiplied by a non-zero number. So that can be taken as symbolically Ri interchanges to Rj, or I can be taken as k times of Ri. Third one, or I changes to Ri plus k times of Rj. So last class we discussed these three. Okay. So we use these two in the problem. Okay. So now move to the problem. So let us take a look at the solution. Solution. Let taken as the capital A. So capital A equals to 1, 3, 2, 7. So this is the matrix, and so you are applying elementary operations right there. For that, you are considering that A equals to IA. So now, what is this A here? The matrix is 1, 3, 2, 7 is the matrix A. What is the matrix I? 1, 0, 0, 1 is the matrix I, and that A is as it is. Now you can apply a elementary operation. So which elementary operation you can apply means, so previous class I explained. So this is R1 and R2. So first of all, to make this element of the R2 means first element of R2 as 0, we can apply the elementary operation. For that we can just take these two. So means this element makes the 0, you should subtract with the R because it only R is there written. So 2, to make it this as a 0, you can multiply with the 2, means 1 into 2, that is same as this according to the problem. That is R into 1 is 1 into 2, both are same one. So means, so now this is 2 is in the second row. So now this element, and we can subtract with first row element. For first row element, you can multiply with the 2. So 2 with the R1 element, that is 2 times of R1. See, 1 into R2 is R2, minus, we can subtract with this and this, we will get that 0. 2 into R2 is 2R1. This and 2 times of this element is both are same one. That's why it is just simple logic here. Now, according to this elementary operation, so which row will change? The second row will change. And which row will as it is? The first row will as it is. So taken as that matrix A. R2 will change, R1 as it is. 1, 3, 1, 0. What about R2? According to this elementary operation, R2 will change. Okay. So first 2 corresponding 1. R2 corresponding 7, R1 corresponding 3, R2 0 corresponding R1 1, R2 1 corresponding R1 is 0. So just apply these elements. R2 is 2 minus 2 into R1 is 1. 2 2 into 1 2. 2 minus 2 is 0. So it's a perfect elementary operation. Now this one, R2 is 7 minus 2 times of R1 is 3. 7, 2 3 is a 6. 7 minus 6 is 1. R2 is 0 minus 2 into R1 is corresponding 1. You can leave 0. Minus 2 into 1 is minus 2. Next, R2 is 1 minus 2 into R1 is 0. 1, 2 into 0 is 0, 1 minus 0 is 1. So this is the first elementary operation. Okay. Now, so to make it as a 1, it is already 1 only. So there is no need to change here. Now, so to make this as a 0. So now this 3 is in which row? It is in the first row. So means obviously R1 will change. To make it as a 0 means you should subtract. Which subtract? R1 and R2 can be subtract. R1 is 3. To make this as a 3, so you can just multiply by 3. So this is to multiply 3. 3 into 1 3. If you subtract, you get that 0. So it is as it is minus. This is R2 element. How much you can multiply? 3 times of R2 or normal. So this and this and this and this. So 1 into R1 is R1. Subtract 3 into R2 is R2. That is same as this, like this only. So that's why, and this one both are same only, no problem. Now, according to this elementary operation, which row will change? First row will change and that second row will be as it is. Second row is 0. So this is to apply the elementary operation. I do this as a multiplier. This is not actual element. Okay. 1 minus 2 1. Now R1. According to this elementary operation, you can write that R1 elements. R1 is 1 minus 3 into R2 element is 0. 3 into 0 0. 1 minus 0 is 1. Next 3 and 1. R1 is 3 minus 3 into R2 is 1. 3 into 1 3. 3 minus 3 is 0. Next R1 is 1 minus 3 into R2 is minus 2. So 1 minus into minus plus 3 2 is 6. So 1 plus 6 is 7. Next R1 is 0 minus 3 into R2 is 1. You can use 0 minus 3 into 1 is minus 8. Okay. See here on the left we will get that identity matrix right. So what is the answer on the right hand side? So this is the inverse. So therefore A inverse. So A inverse will be equals to 7 minus 3 minus 2 1. So this is how to find the inverse of a matrix by using the elementary transformation or elementary operation that is towards. Got it? Move to the next one. Okay, next question. Two, one, one, one. So this is the matrix. For this, to find the inverse. So let us capital A will be equal to the matrix 2, 1, 1, 1. So now you are writing that A is equals to IN because you are applying the elementary row operation. So what is that A is? So A is 2, 1, 1, 1 equals. What is that? I is 1, 0, 0, 1 into A. So this is the first row and this is the second row. to make it the element of R2 as the first element as a 0. So for that you can change the which row? Second row will be changed. For that you can do just a multiplication. So which one you can take that? 2 into R2 is 2 times of R2, that is twice of R2, and you can subtract that. 1 into R1 is just R1. Otherwise, so this is the element in R2, this is the element in R1. To make this as a 0, so it is obviously to write for this, you can just multiply by 2. So now this is in which row? Second row, that is twice of R2. And mass you can subtract. This is in which row? First row. You can subtract, that is minus of R. That's it. So both are same one. Okay. So now, according to the R2 changes to 2R2 minus R1, you can write the matrix. Here R1 will say R2 will changes. So 2, 1, 1, 0. This is the first one. So now second one will change according to this elementary operation. So already you know the corresponding elements. For 1, 2. For 1, 1. For 0, 1. For 1, 0. We can apply here. 2 times of, that is twice of. R2 is 1 minus R1 is corresponding element for 1. You can get the corresponding element of R1 is 2. Corresponding element of R2 1. Corresponding element of R1 is 2. Corresponding element of R2 1. Corresponding R1 element is 1. Corresponding element of 0 for in R2 is corresponding element of in R1 is 1, like that. 2 into 1, 2. 2 minus 2 is 0. So the next step, 2 into, again R2 element is 1. Corresponding R1 element is 1. 2 into 1, 1. 1 minus 2 minus 1 is 2 into 1 is 2. 2 minus 1 is 1. Next, this and this 2 times of twice of R2 is 0 minus R1 is 1. 2 into 0, 0. 0 minus 1 is minus 1. Next, this and this. Twice of R2 is 1 minus R1 is 0. 2 into 1, 2. 2 minus 0 is 2. So you got the first step. Now, to make this as 0. Why you cannot do this means it is already 1. Again, there is no need to convert. So to make this as a 0, it is in which row? It is in R1 and R2. So now to make 1 as a 0, the element is in first row. Means R1 can be changed as, means you can take these two right there. This and this both are same only. If you just simply subtract that row means you will get that. So this is R1 minus R2, or simply. About the logic right there. Which one? 1 into R1 is R1 minus 1 into R2 is R2. So that is also you get the same elementary operation only. Now you can write the next step. According to the elementary operation, R1 changes to R1 minus R2. So for this elementary operation, R1 will change, R2 will be as it is. So R1 can be changed, right? Otherwise first write that R2. R2 will be as it is. 0, 1, minus 1, 2. So now R1 can write as R1 minus R2. R1 minus R2. 2 minus 0. 2. R1 minus R2. 1 minus 1 is 0. R1 minus R2. 1. Minus of minus becomes plus 1. So 1 minus of minus 1. R1 is 1. Minus R2 is minus 1 right? So minus of minus becomes plus 1. Total 1 plus 1 is how much? It is 2. Next, R1 is 0. Minus R2 is 2. 0 minus 2 is minus 2. So this is the next step. Okay. Now it is 0 and 1. It is 0. Now to make this as the 1. So it is in which row? It is in first row. So previous class we did the problem. To make it as the 1. ಅಂದ್ರೆ ನಾವು 1 ಮಾಡಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? ಆ ಎಲಿಮೆಂಟ್ ಯಾವ ರೋ ನಲ್ಲಿ ಇರುತ್ತೆ ಆ ರೋ ನ ಸೇಮ್ ನಂಬರ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದಾಗ you will get it as a 1. Now this is 2 in which row? It is in first row. So obviously you can divide the first row with 2. That is R1 can be changed as R1 by 2. ಅಂದ್ರೆ R1 ಇರೋ ಎಲಿಮೆಂಟ್ಸ್ ನ 2 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಅದು 2 by 2 ಏನಾಗುತ್ತೆ? So obviously 1 ಆಗುತ್ತೆ. Now according to that elementary operation, so write the matrix. So here also R1 will change, R2 will be as it is. What is that R2? 0, 1, minus 1, 2. This is that R2. What about R1? R1 can be changed according to this elementary operation as R1 by 2 because the element here is 2, right? To make it as a 1, so you can divide by 2. To make it as, suppose if it is 3 is there, to make it as 1, divided by 3. Suppose here minus 5 is there, to make it as 1, so divide by with minus 5. It is in first row, you can take it as a first row. If it is in second row, you can take it as a second row. Now take that 2 by 2. 1, 0 by 2, 0, 2 by 2, 1, minus 2 by 2, minus 1. So this is the given matrix. Okay, after applying that, R1 changes to R1 by R2. Now, in the last step, so this is identity matrix, right? So, what is the answer obtaining on the right hand side? Obviously, that is the inverse. So, therefore, A inverse will be equals to 1, minus 1, minus 1, 2. So, this is the required matrix. Got it? So, see first, you are changing as R2. Next, you are making as R1 because it is already is 1. So, that's why you can move to the next step here. That is R1. So, we got that 0. Now to make it as a 1, so just divide with that same element. We will get that required answer. Got it? So we can move to the next one. So next, fifth one. Two, 3, 5, 7. Okay. So same. Let A is equals to solution 2, 3, 5, 7. You are applying that elementary operations, right? A is equals to A. Write that A. What is that A is? 2, 3, 5, 7. So this is the matrix A. What is that? Matrix I 1, 0, 0, 1 is the matrix I into A. So it is that R1, it is the R2. To make it as a 0, you can apply the elementary operation as. So it is in R2, right? So R2 changes to what you can do? Just multiplying, that's all. So it is just imagine, okay, it is not exact R1 and R2, okay. So it is just imagine that when it is R1 and R2 is there. So just to make it as an elementary operation, we are just imagining or we are just multiplying it. So now, which you can do? 2 into R2. 2 times of R2 and you can subtract 5 into R1. So 5 times of R1. Otherwise, if it is normal means 5 and 2 both are different. To make it as a 0, for this you can multiply with 2. 5 2s are 10. For this you can multiply by 5. 2 5s are 10. So 10 minus 2 becomes 0, right? So it is in R2, you are multiplying with 2. It is in R1, you are multiplying with 5. That is 5 times of R1 and you can just subtract that one. So to make both should be equal. So that's why I am multiplying the corresponding numbers. Now, according to the R2, you can write the matrix. Okay. R1 as it is right. 2, 3, 1, 0. It is R1. R2 can be changed as 2 times of R2 minus 5 times of R1. So 2 times of, what is that R2? 5 minus 5 times of, what is that R1? Is 2. 2 5s are 10, 5 2s are 10. 10 minus 10 is 0. Next, 2 times of R2 is 7 minus 5 times of R1 is 3. See, 2 times of R2 7 minus 5 times of R1 is 3. 2 7s are 14, 5 3s are 15. 14 minus 15 is minus 1. Next, 2 times of R2 is 0 minus 5 times of R1 is 1. 2 times of R2 minus 5 times of R1. 2 into 0 is 0. 5 into 1 is 5. With minus you will get minus 5. Next, 2 times of again R2. R2 is 1 minus 5 times of R1 is 0. 2 times of R2 minus 5 times of R1. 2 times of 1 minus 5 times of 0. 2 into 1 to 5 into 0 is 0. 2 minus 0 is obviously you get 2 1. Okay. Now next, to make this as a 1. To make this as a 1, you can divide by minus 1 or you can multiply by minus 1. Both are same only. Nothing will change here. Okay. So it is R1. It is R2. So to make this as a 1, so R2 I will change this as a minus R2. If you divide by minus 1 is also same, or if you multiply by minus is also, both are same only, nothing will change here. Okay. Now taken that R1 as it is, and R2 can be changed as minus times of R2. So 2, 3, 1, 0. For R2 you can change with minus. 0 minus 0 is 0 only. Minus of minus 1 is plus 1. Minus of minus 5 is plus 5. Minus of 2 is minus 2 only. Or if you divide by minus 1 is also, both are same. 0 by minus 1 0. If it is minus 1, divide by minus 1. Minus 1 by minus 1 1. Minus 5 by minus 1 5. 2 by minus 1 minus 2. That's it. Both are same one. If you multiply by minus or you divide by minus 1 also, both are same one. Okay. Next, this 3 can be made as a 0. So R1 and R2. Now see here, that 3 is in which row? It is in first row. To make it as a 0, what you can do? You can subtract. Which row you can subtract? You can subtract the second row, right? So R1 can be changed as. So this is in R1. To make it as a 0, you can subtract this with this element. So this is 3. To make it as 3, what you can do? We can multiply by 3, right? So if you multiply by 3, 3 into 1. 3, so 3 minus 3 is 0. Now this 3 is in which row? It is in first row. R1 minus. We can subtract that. So this is in second row. For the second row, which element you are multiplying? You are multiplying 3, right? That is 3 times of R2 or normal. 1 into R1. R1. 3 into R2. 3 R2 with subtraction. So both are same only. Now, according to this elementary operation, that is R1 changes to. So we can write the remaining elements with the R2 as it is. So first we can complete that R2. R2 is 0, 1. So you cannot write this multiply by 3. So this is for elementary operation. I took the in this problem. Okay, don't need to write that multiply by 3. So 0, 1 and 5 minus 2. Okay, now R1 will change, right? According to the elementary operation. R1 is 2 minus 3 times of. What is it? R2? R2 is 0. 3 into 0, 0. 2 minus 0 is 2. Okay, next. R1 is 3 minus 3 times of R2 is 1. 3 into 1, 3. 3 minus 3 is 0. Next. R1 is 1 minus 3 times of R2 is how much? It is 5. So 1, 3, 5 is 15. So 1 minus 15 is minus 40. Okay. Next, R1 is 0 minus 3 times of R2 is minus 2. Okay. So 0. So this minus into minus becomes plus. You will get 3 2s are 6. Got it? Now what you can do? So you can complete that R1 changes to. Now, so this element 2, right? It is in which row? It is in first row. What you can do? To make it as 0? No. To make it as 1, what we can do? To make it as a 1, so just divide that element with the same number. It is 2, so that's why it should be divided by 2. So now R1 can be changed as R1 by 2 and R2 will be as it is. So what is that R2? 0, 1, 5 minus 2. Okay. Now R1 can be changed as R1 by 2, right? 2 by 2. 1, 0 by 2, 0, minus 14 by 2 is minus 7, 6 by 2 is 3. So on the left hand side you get identity matrix. So on the right hand side what you are getting, that is an inverse. So A inverse will be is equals to minus 7, 3, 5, minus 2. So this is the inverse. So last class I explained one small logic, whether the given answer will be correct or not. Okay, for that what is the formula I applied? 1 by AD minus BC D minus B minus C A. So what is this means? In the matrix, diagonal elements will interchange. For non-diagonal you can change the sign. So for that 1 by AD means 2 into 7 14, BC means 3 into 5 is 15. And what are the diagonal elements? We can interchange. So 2 and 7 becomes 7 and 2. For non-diagonals you can change the sign later. That is minus 3 and 5 according to this one. 14 minus 15 minus 1. 1 by minus 1 is minus 1. Multiply with minus 1 in all the elements. So minus 7 and 3 and 5 minus 2. See, minus 7, 3, 5 minus 2. Correct? According to this one, you can just check. But in the problem you cannot do. This is only for just checking the given problem. So got it? So this is how to find the inverse of a matrix by using elementary row operations, and this is very important for the 3 marks question. Okay. So same, move to the one more problem. So next, 6th one. 2, 1, 7, 4. So okay. So let us write a solution. 2, 1, 7, 4. You are applying that A is equals to I. So what is that A is? So A is 2, 1, 7, 4. This is A. And what is this I is 1, 0, 0, 1. And A as this. Now first what you can do? Obviously to make this as a 0. So R1 and R2. So now tell me, so it is in which row? It is in second row. So obviously which will change? R2 will change. How we can change? See, these two can be subtracted. Is these two are same? No. For that what you can do? If you multiply this with 7, 7 to the 14. If you multiply this with 2, 7 to the 14. And you can subtract this one, you will get 0 later. Now it is in which row? Second row. You can multiply how many times? That is 2 times the R2. With subtraction, this is in which row? First row. For this multiply how many times? 7 times. 7 times of R. That is 7 times of R. Or normal, you can take a logic means 2 into R2, 2 times of R2 minus 7 into R1 is 7 times of R1. Both are same one. Okay. Now, according to the R2 will change, right? R1 will be as it is. What is that R1? 2, 1, 1, 0. R1. R2 can be changed according to this elementary operation. Okay. That is 2 times of R2 is 7 minus 7 times of R1 is 2. 2 sevens are 14, 7 twos are 14. 14 minus 14 is 0. Next, 2 times of R2 is 4 minus 7 times of R1 is 1. 2 into 4, 8. 7 into 1 is 7. 8 minus 7 is 1. Next, 2 times of R2 is 0 minus 7 times of R1 is 1. 2 into 0, 0 minus 7 into 1 is minus 7. Next, 2 times of R2 is 1 minus 7 times of R1 is 0. 2 into 1 is 2, 7 into 0 is 0. So 2 minus 0 is obviously you get 2 only. So got this one. Okay. It is 1. Is it convert? So no need to convert it is already 1 only, no problem. Now, so this one. So now that 1 is in which row? It is in first row. So to make it as a 0, you can subtract this element with this element, then it will become 0. Is this 1 minus 1 is 0, right? So again there is no need to multiply for this and for this. Okay, right? This is R1 as it is, and this is the R2 as it is. Because if you directly subtract means 1 minus 1 will get 0 only. So there is again no need to multiply with any number. So R1 will change, R2 will be as it is. So first of all, write that R2 only. 0, 1, minus 7, 2. Okay. R1 can be taken as R1 minus R2, right? Just subtract. 2. R1, R2 is 0. 2 minus 0, 2. R2, R1 1, R2 1. 1 minus 1 is 0. R1 1, R2 minus 7. With minus sign, minus of minus becomes plus 7. So 1 plus 7 is 8. Next, R1 0, R2 2. 0 minus 2 is minus 2. Got it? So now we got the next elementary operation. Now, so this is already got 0, and to make this as the 1. Now, to make this as the 1, so what the procedure we are doing? So we are just dividing that row with the same element which is present in that row. So now it is in which element? 2. So for that you can divide R1 with 2. You will get the required matrix. R1 can be changed as R1 by 2. R1 and 2 in the divide multiplier. So what about the R2? R2 will be as it is. So first write that R2 0, 1, minus 7, 2. This is R2. So R1 ಏನು ಮಾಡಬೇಕಲ್ಲಿ? So ಎಲ್ಲ elements ನ 2 ಇಂದ divide ಮಾಡಬೇಕು. So 2 by 2. 1, 0 by 2 is 0. 8 by 2 is 4. Minus 2 by 2. Minus 2 by 2 is minus 1. So it's the last step. It is identity matrix. So what is the answer on the right hand side? That is obviously the, what is that obviously? So that is the inverse of the given matrix. So that is A inverse will be is equals to 4 minus 1 minus 7 2. So this is the inverse by using the elementary row operations. Okay. So see once again, you can do one more problem. You see here? So let A is equals to 2, 5, 1, 3. You are applying that A is equals to A means elementary row operations. What is it here? 2, 5, 1, 3. So this is A. What is this? I is 1, 0, 0, 1 into A. So first, to make it as a 0. So it is in which row? It is in second row, right? Obviously, which row will change? R2 will change. R2 can be changed. How we can change? So this can be subtracted with this. It becomes 0. So it is 2. To make it as a 2, what you can do? You can just multiply with 2. So it becomes 2 into 1, 2. So this is 2. So 2 minus obviously 0, right? So it is in which row? Second row. For second row, you are multiplying with 2. That is 2 times of R2. And for the R1, so there is no multiply means you can just write that R1 and you can subtract that one. So see, 2 into R2, 2R2 minus 1 into R1, R1, that is about the logic. Okay. Now, according to that R2 elementary operation, we can write the elements in the R2. And what about that R1? R1 will be as it is. R1 is 2, it is 5, and 1, and 0. According to R2, we can change right 2 times of. What is this R2? R2 is 1 minus R1 is 2. 2 into 1 is 2. 2 minus 2 is 0. Next, 2 times of. What is this R2? R2 is 3 minus R1 is 5. So 2 into 3 is 6. 6 minus 5 is 1. Next, 2 times of. So R2 is 0 minus R1 is 1. 2 into 0 is 0. 0 minus 1 is minus 1. Next, 2 into R2 is 1 minus R1 is 0. 2 into 1 is 2. 2 minus 0 is 2. So this is the first. Okay. Next, it is already 1. Is it possible? Is it no need to convert? Is it a need to convert? No need to convert, right? You can leave that one. Next, this 5. So it is in which row? It is in first row. So to make it as a 0, you can subtract this element with this element, means R1 with R2. For that elementary operation, you can write as R1 changes to. It is in which row? First row. It is in which row? Second row. It is 5. To make it as a 0, we can multiply this 1 with 5. Then it becomes 5. 5 minus 5 becomes 0, right? Now it is R1 with, for this R2 you can multiply how many times? 5 times of R2 means then this element becomes 0. Okay. Now, 1 into R1. R1 minus 5 into R2, 5 R2. So that is same the previous logic I explained. So now write the R2 as it is, and R1 will change according to the elementary operation. So 0, 1, minus 1, 2. Okay. So change that R1. R1 is 2 minus 5 times of R2 is 0. 2. 5 into 0, 0. 2 minus 0 is 2. Next, R1 is 5 minus 5 times of, again R2 is 1. 5 into 1, 5. 5 minus 5 is 0. Next, R1 is 1 minus 5 times of R2 is minus 1. Minus 5 into minus 1 plus 5. So 1 plus 5 is 6. Next, R1 is 0 minus 5 times of R2 is 2. So R1 is 0 minus 5 times of R2 is 2. 0. You can leave. Minus 5 into 2 is minus 10. So you got that? So next one. So now the last step. So to make it as 1. So it is in R1. To make it as an 1, so what we can do? We can just divide that row with that element. So which row? R1. Which element? 2. To divide by 2 means you will get that 1. So apply the elementary operation as R1 changes to R1 by 2. So R1 and elements na 2 in the divide model. So R2 will be as it is, and R1 will change. What is that R2? 0, 1, minus 1, 2. This is that R2. What about R1? So just divide with all the elements of R1 with 2. 2 by 2, 1. 0 by 2, 0. 6 by 2, 3. Minus 10 by 2, minus 5. So you got the identity matrix. So on the right hand side what you got? So that is the inverse. So therefore A inverse will be equals to 3 minus 5 minus 1, 2. So this is the inverse. You see once again, and we will move to the next. 3, 1, 5, 2. Okay, let us consider the solution for this problem. So A equals to 3, 1, 5, 2. You are taken that A equals to I. What is that? A is 3, 1, 5, 2 equals. What is that? I is 1, 0, 0, 1 into A. So now, to make it as a 0, so it is in which row? It is in second row. It is the first row. To make it as an element of R 5 can be 0. So you can change R2, right? So how you can change? You can subtract these two, means you should make these two which will be equal. For this, multiply by 3 means 3 5 is 50. For this, multiply by 5 means 3 5 is 50. So 50 minus 50 becomes 0, right? So for the element of R2, you can multiply with 3. That is 3 times of R2 and subtract. In the element of R1, you can multiply with 5. That is 5 times of R1. Or normally, 3 into R2, 3 R2 minus 5 into R1, 5 R1. It is same elementary operation. And R2 will change, R1 will as it is. So first, write down that R1, 3, 1, 1, 0. So R2 can be changed right according to the elementary operation. So that is 3 into, what is this R2? R2 is 5 minus 5 times of R1 is 3. 3 into 5, 15. 5 into 3, 15. 15 minus 15 becomes 0. Next, 3 times of, what is that? R2? R2 is 2 minus 5 times of, what is that? R1? R1 is 1. 3 into 2, 6. 5 into 1, 5. 6 minus 5 is 1. Next, 3 into R2 is 0 minus 5 times of R1 is 1. 3 into 0, 0 minus 5 into 1 is minus 5. Next, 3 times of R2 is 1 minus 5 times of R1 is 0. 3 into 1 is 3, 5 into 0 is 0. So 3 minus 0 will get so 3 only. Okay, so you got the first term. It is 1, no need to convert. So it is in R1. So R1 and R2. To make it as a 0, you can subtract this element with this element. Is to both are same only, right? If you subtract this, obviously you get 0 only. So again there is no need to multiply any number. So R1 can be changed as R1 minus R2. So then that element becomes 0. So R1 will change, R2 will be as it is. So first write down that R2 is 0, 1, minus 5, 3. Write that R1 as R1 minus R2. 3 minus 0 is 3. 1 minus 1 is 0. 1 minus of minus becomes 1 plus 5. So 1 plus 5 is 6. 0 minus 3 is minus 3. So just subtracting R1 minus R2. And the last step. So it is in R1. To make that as a 1, you can divide with which number? You can divide with number 3. For the which row? For the first row. That is R1 can be changed as R1 by 3. Divide all the elements of R1 with 3. So what about the R2? R2 will be as it is. That will not change. Write that R2. 0, 1, minus 5, 3. So what about the R1? R1 can be divided with 3, right? So 3 by 3 is 1. 0 by 3 is 0. 6 by 3. 6 by 3 is 2. Minus 3 by 3. So minus 3 by 3 is minus 1. So left hand side you got the identity matrix. Right hand side what you are getting? So that is the inverse. So therefore A inverse will be equals to 2 minus 1 minus 5. So 3. So this is the required answer. Okay, move to the 1. 4, 5, 3, 4. Okay, see the solution. Let capital A will be equals to 4, 5, 3, 4. Elementary operation means to apply elementary or element operation means you have to write the condition. A is equals to I. What is that? A is 4, 5, 3, 4. This is A. So what is that? I 1, 0, 0, 1 into A. First of all, to make this element as 0, so it is in which row? R2, right? So to make it as a 0, what you can do? So what is the elementary operation you can apply? That is in the second row. Second row can be changed as. For this, if you multiply by 4, because to make this one equal, right? So just 3 4s are 12 means you can multiply 4 3s are 12. 3 4s are 12, 4 3s are 12. And if you subtract means you get 0, right? For the element in R2, we are multiplying with 4. 4 times of R2 and subtract. The element in R1 we are multiplying with 3, that is 3 times of R, or normally 4 into R2 4 R2, 3 into R1 3 R1, and write the next step. So R2 can be changed and R1 will be as it is. So what is that R1? R1 is 4, 5, 1, 0. What about R2? R2 will change. How it will be changed? 4 times of what is an R2? R2 is 3 minus 3 times of R1 is 4. See, this is R2 and this is corresponding R1. 4 into 3 12. 3 into 4 12. 12 minus 12 will get 0. Next, 4 times of what is the R2? R2 is 4 minus 3 times of R1 is 5. 4 into 4 16. 3 into 5 15. 16 minus 15 you will get 1. Next, 4 times of R2 is 0 minus 3 times of R1 is 1. 4 into 0 0 minus 3 into 1 is minus 3. So next again 4 times of R2 is 1 minus 3 times of R1 is 0. 4 into 1 4 minus 3 into 0 is 0. That is 4 minus 0 is we get 4. Okay, so got that one. So next it is already 1. I now need to convert. And to make it as a 0. So to make it as a 0, what we can do? We can just subtract, right? So this element with this element. So it is already 5. So it is 1. To make it as a 5, we can multiply with 5. It becomes 5 into 1 5. Now it is 5 minus 5 0, right? So now that 5 is in which row? It is in R1. For this, you are not multiplying any number. So write R1 as it is and you are subtracting. For the R2 element, you are multiplying with 5 items, which is 5 times of R2. Now, according to the elementary operation, R1 will change and R2 will be as it is. So, what is that R2? We can write as it is. That is 0, 1, minus 3, 4. And according to R1, we can change, right? R1 is 4 minus 5 times of R2 is 0. 4. 5 into 0 is 0. What is 4 minus 0? 4 minus 0 is 4. Next, R1 is 5 minus 5 times of R2 is 1. 5. 5 into 1, 5. 5 minus 5 is 0. Again R1 is 1. Minus 5 times of R2 is minus 3. Minus 5 into minus. Minus minus becomes plus. 5 3 is 15. 15 plus 1 is 16. Next, R1 is 0. Minus 5 times of R2 is 4. We can leave that 0. Minus 5 into 4 is minus 5 for the 20. So got that one. Next, the last step. So it is in R1. What you can do? To make it as a 1. To make it as a 1, what you can do? You can divide element in the R1 with the same number. What is the same number you got? 4. We can divide with 4 means we will get the required answer. That is R1. R1 can be changed as R1 by 4. You can divide with 4 means you will get that answer. Now R1 will change. What about R2? R2 will be as it is. So that will not change. So R2 is 0, 1, minus 3, 4. R1 will change according to R1 by 4. So 4 by 4 is 1. 0 by 4 is 0. 16 by 4. 16 by 4 is 4. 4 is 16. Minus 20 by 5 means 4 5 is 20 with minus 5. So left hand side you got the identity matrix. So right hand side is that inverse. So therefore A inverse will be equals to 4 minus 5 minus 3 4. So this is the inverse. Got it? So see once we can move to the next one. Okay, see the solution of this one. Let A equals to 2 minus 6 1 minus 2. You are taken that condition as A equals to IA. So what is that? A is a given matrix 2 minus 6 1 minus 2 is a A, and what is that? I is a 1 0 0 1 into the matrix A. So now first row and it is second row. So to make this element as obviously 0. For this is 1. We can subtract with this element. So this is 2, right? To make it as 2, you can multiply with 2. Now it is in R2, so means R2 only will changes. R2 changes to. For the R2 element, you are multiplying how many times? Twice, right? 2 times R2 minus R1, you are not multiplying any element, right? R1 only. Now R2 will change, R1 will as it is. So write R1. R1 is 2 minus 6 1 0. R2 can be changed, right? 2 times of R2 is 1 minus R1 is 2. 2 into 1 2. 2 minus 2 is 0. Next, 2 times of what is this? R2. R2 is minus 2 minus R1 is minus 6. So that minus 2 minus becomes plus 6. 2 into minus 2 minus 4. Minus 4 plus 6 is 2. Next, 2 times of R2 is 0 minus R1 is 1. 2 into 0, 0. 0 minus 1 is minus 1. Next, 2 times of R2. R2 is 1 minus R1 is 0. 2 into 1 is 2. 2 minus 0 is obviously it is 2 only. Right? Now, so same R1 and R2. You got 0. So next, to make it as a 1, you can make it as 1 thing. What you can do? You can divide by right. So you can divide by same element. So it is in R2 right. So R2 changes to R2 by 2. All the elements of R2 can be divisible 2 means so to make it as a 1 you are dividing with 2. So it is applied to the all the elements of R2. So R2 can be changed and R1 will be as it is. So what is that? R1 2 minus 6 1 0. What is that? R2 0 by 2 0. 2 by 2 is 1. Minus 1 by 2 is minus 1 by 2 only. And 2 by 2 is 1. So this is the next step. Now, so what you can do? To make it as a 0. So right there. So now it is in which row? It is in first row. Okay. So let us write the elementary operation as, that is R1 changes to. So R1 changes to. So this is minus 6 and for this you can multiply with just 6. 6 into 1 6. So if it is minus 6, if it is plus 6, if you add these two, obviously it becomes 0. Now this is as it is R1 plus why it is plus? This already minus element is there. It is plus element. 6 into 1 6 means plus element. So minus element plus element becomes 0 right? Minus 6 plus 6 times of R2 to make it as a 0. Let's see whether the 0 will come or not. Okay. So according to this one, R1 will change. R2 will be as it is. First of all, complete that R2. So 0, 1, minus 1 by 2 and 1. Next, R1 can be changed as R1 plus 6 R2 right? R1 is 2 plus 6 times of 2 plus 6 times of R2 is 0. 6 into 0, 0. 2 plus 0 is 2. Next, R1 is minus 6 plus 6 times of R2 is 1. Minus 6, 6 into 1 6. So minus 6 plus 6 is 0. So that's why we will take that plus. But here subtracted. Here adding the different elements to make it as a 0. Next, R1 is 1 plus 6 times of R2 is minus 1 by 2. R1 corresponding R2. 2 1s are 2 3s are. So 1 plus into minus minus 3. So 1 minus 3 is minus 2. Next, R1 is 0 plus 6 times of R1 is 0 plus 6 times of R2 is 1. 0. 6 into 1 6. 0 plus 6 is 6 only. Okay. Now next step, the last step. So this is 2. It is in R1. What you can do? To make it as a 1 right? So for that, what is the elementary operation we can apply? R1 can be changed as R1 by 2. If you divide it 2 means obviously it becomes 1 only. So R1 can be divided into 2 means all the elements of R2 can be divided with 2. And R2 will be as it is 0, 1, minus 1 by 2, 1, 2 by 2, 1, 0 by 2, 0, minus 2 by 2, minus 1, 6 by 2 is 3. So left hand side you got the identity matrix. So right hand side what you are getting? That is the inverse. So therefore A inverse equals to minus 1, 3, minus 1 by 2, 1. So this is the required answer. So we can move to the one more problem. 3 minus 1 minus 4 2. Okay, let us take the solution. Let capital A equals to 3 minus 1 minus 4 2. You are taken that A equals to I. So what is that? A is 3 minus 1 minus 4 2 equals, what is that? I is 1 0 0 1 into A. Okay. So first what you can do to make it as a 0? It is in which row? It is in second right. So means R2 changes to. So this and this can be now, it is not subtraction, it is addition, because it is minus element, it is a plus element, it is negative element, it is positive element. For that, if you multiply with 3, 4 3 is 12. If you multiply with 4, 3 4 is 12. 4 3 is 12, 3 4 is 12. So you have minus 12 and this plus 12. If it plus means it becomes a 0 right. That is 3 times the R2. Next, with how many times? 4 times of R1 becomes 0. Okay, let's see whether that element will be 0 or not. Let's see. Equals. So here R2 will change, R1 as it is. So 3 minus 1, 1, 0. What is that R2? 3 times of R2 right? 3 times of R2 is minus 4 plus 4 times of R1 is 3. 3 4 is 12 minus 12, 4 3 is 12 plus 12 minus 12 plus 12 is 0. Got it right? Next, 3 times of R2 is 2 plus 4 times of R1 is minus 1. 3 2 is 6, 4 1 is 4 into minus 1 minus 4. 6 minus 4 is 2. Next, 3 times of R2 is 0 plus 4 times of R1 is 1. 3 into 0, 0. 4 into 1, 4. 0 plus 4 is 4. Next, 3 times of R2, 1 plus 4 times of R1 is 0. 3 into 1, 3. 4 into 0, 0. 3 plus 0 is 3. Right. Next, to make it as 0 or 1, to make it as a 1, what we can do? We can divide with the same number. It is in R2, we can divide with the same number is it is 2 only. So divide all the elements of R2 with 2 and R1 will be as it is. First of all, write down that R1, 3 minus 1, 1, 0. What after R2? Divide with 2 right? 0 by 2, 0, 2 by 2, 1, 4 by 2, 2, 3 by 2 is 3 by 2. It is not exactly divisible. So write that as it is. Now, next. So it is in which row? It is in first row. To make it as a 0, we can link these two elements right. It is minus 1 and it is plus 1. If you add these two means minus 1 plus 1 becomes 0 right. So what is the elementary operation we can apply means? So there is no need to multiply any number because the elements in the both rows will be same. If you just simply add means you will get that 0. That is R1 can be changed as just simply add that R1 with corresponding elements of R2. So this with these elements. Now R1 will be changed and R2 will be as it is. What is that R2? 0, 1, 2, 3 by 2. And what about R1? 3 plus 0. R1 plus R2 right? 3 plus 0, 3. Minus 1 plus 1, 0. 1 plus 2 is 3. 0 plus 3 by 2 is 3 by 2 only. Right? So in the last step, what we can do? We can just divide with the 3 because to make it as a 1, it is in first row. To make it as a 1, you can divide with the 3 like that. So R1 can be changes as R1 by 3. All the elements of R1 can be divisible with the 3. So R2 will be as this. What is R2? 0, 1, 2, 3 by 2. So divide all the elements of R1 with 3 like that. 3 by 3, 1. 0 by 3 is 0. 3 by 3 is 1. 3 by 2 divided by 3. So 3 by 2 divided by 3 means, so this 3 getting cancelled, this 2 comes to denominator. It becomes 1 by 2. Okay. So left hand side we got the identity matrix. So right hand side will be the inverse. So therefore, A inverse will be equals to 1, 1 by 2, 2, 3 by 2. So this is the required matrix. So this is how you can find the inverse of a matrix by using elementary transformations, and this is very important for the 3 marks question. Okay. In the next class, we can discuss some more problems on the inverse of a matrix. So in that, so just a small concept is, so previous class I explained note writer means if you apply the any elementary operations, a row or 2 rows or columns, if you are getting all the elements are zeros, so the matrix inverse does not exist. Right? In that concept, we can do the some more problems on the next class. Okay.